Welcome to today's lecture on the different states of matter. We will explore the fundamental properties of solids, liquids, and gases, as well as the processes involved in the transitioning between these states. By the end of this lesson, you should be able to define each state, discuss their properties, and describe how matter changes between these states. At the end of this session, you will be able to define the solid, liquid, and gaseous states of matter. We will also explore the properties of each state in details and describe the changes that occur as matter transitions from one state to another. You may try the trigger activity by scanning the QR code. This image represents the three states of matter: solid, liquid, and gas. On the left, we have ice, which is in the solid state. The particles are closely packed together in a fixed structure, giving it a definite shape and volume. In the middle, we see water, the liquid state of matter. Here, the particles are still close together, but can move and flow past each other, allowing the liquid to take the shape of its container. On the right, we observe the gaseous state, represented by the vapor trapped inside the inverted glass. In gases, the particles are far apart and move freely, filling the entire volume of the container. Together, these three forms demonstrate the primary states in which matter can exist under different conditions of temperature and pressure. Plasma is one of the four fundamental states of matter, alongside solid, liquid, and gas. It consists of a hot ionized gas where a significant number of atoms have been stripped of electrons, resulting in a collection of positively charged ions and free electrons. Solids are characterized by closely packed particles that are arranged in an orderly pattern. The particles can vibrate, but are unable to move freely. Solids have a fixed shape and volume and cannot be compressed easily due to the strong forces of attraction between particles. This is why solids typically have a high boiling point and density. Liquids have particles that are packed closely but in a disorderly fashion. While the particles are still near each other, they can move past one another, allowing liquids to flow. Liquids have a fixed volume but no fixed shape, and like solids, are not easily compressible. The forces of attraction between particles are weaker than in solids, but still significant. Gases have particles that are much further apart compared to solids and liquids. These particles move randomly and at high speeds, leading to weak forces of attractions between them. Gases have neither a fixed shape nor volume and are easily compressible due to the large distances between particles. This slide illustrates how particles are packed in solids, liquids, and gases. You can observe the tightly packed particles in solids, the looser arrangement in liquids, and the large distances between particles in gases. The differences in density between these states are directly related to the distances between particles. In this slide, we compare the three states of matter, solids, liquids, and gases, based on various properties. For solids, the particles are closely packed in an orderly arrangement, and the forces between them are very strong. The particles vibrate in place, giving solids low internal energy. Solids have high density and are not compressible due to the lack of empty spaces between particles. For liquids, the particles are still close together but arranged more randomly with moderately strong forces between them. The particles can slide past each other, leading to moderate internal energy. Liquids are also not compressible and have quite high density, though lower than solids. In gases, the particles are far apart and move freely with very weak forces between them. This results in high internal energy. Gases have low density and are compressible because there is ample space between the particles. Remember, internal energy is the sum of the kinetic and potential energy of all the particles in a substance, and it plays a critical role in defining the state of matter.